Okay, this lecture will take you through the basic building blocks that are going to be needed for each of your different types of dehydration synthesis reactions. The saccharides, remember, you can have monosaccharides, and monosaccharides, remember, which are your single sugars. We can create also disaccharides, which are your double sugars. The way that plants transport sugar, find it in beets, sugar cane. Another easy way to get energy. Disaccharides can easily be broken down into monosaccharides by hydrolysis reactions. Remember, these guys, because of all the hydroxyl groups, they love water, so they can easily be broken down. And then you have your polysaccharides, which are your mini sugars. So polysaccharides, remember, the polysaccharides were your polymers, meaning that they had many monomers of single sugar joined together by dehydration synthesis reactions. The key molecule that you need to know that we're going to be using as a building block is going to be glucose, and we will be using alpha glucose. So I'm going to draw an alpha glucose molecule. That CH2OH group up at the top, and then we're going to bring in our other parts. Okay, so we're going to have a hydrogen here and a hydroxyl group there. We're going to have another hydrogen here and our other hydroxyl group here. Notice that the oxygen is always coming off of this carbon, okay? We're going to have a hydroxyl group here, and then a hydrogen bonded there. And then we'll have a hydroxyl group here, and a hydrogen bonded there. Now, if we were to put numbers at each carbon, because remember we said the corners here represent the carbon, so we would say that this is number 1, that's number 2, that's number 3, that's number 4, that would be number 5, and then this would be your 6th carbon way up there. That's your CH2OH group. But that's the building block for the saccharides for your purpose. All right, so let's move on to the next slide. Now, lipids. Remember, these included the fats, the oils, the fats, the oils, the steroids. Okay, the most common molecule that we're going to look at is the triglyceride. You would not have to draw a steroid. So let's look at the basic building blocks for the lipids. The lipids, remember, had to have a 3-carbon alcohol group. Remember, alcohols always have the functional group, the hydroxyl group, attached. And then we said that we would join this with 3 fatty acids. I'm only going to draw, well, actually, I will draw 2 fatty acids just to remind us that fatty acids can be saturated in hydrogen, or they may be unsaturated. So I will draw a fatty acid that is saturated in hydrogen. Remember, our fatty acids are going to have a carboxyl group at the end of them, which is what's going to make them acidic. And then they're going to have a long hydrocarbon chain. So this represents the long hydrocarbon chain. And normally it's an even number, so that's 1, 2, 3, and this will be 4, 5, and 6. You can tell I don't have very much room. I'm going to run out of room. And so it's saturated in hydrogens. So this is a fatty acid, but it is a saturated fatty acid because it is saturated in hydrogens. Now we could also draw an unsaturated fatty acid. So again, we still have to have the portion of the molecule that makes it acidic, which is this carboxyl group that is attached to this fatty hydrocarbon chain. Remember, we want to make sure that each of the carbons only has 8 electrons. So this is 2, 4, 6, 8. The next one, if we put a double bond in here, then we can put a hydrogen here, and he still has 2, 4, 6, 8. We can go in and we can put another double bond in here, and this one 2, 4, 6, so that means we still have to add another hydrogen. And then we can go on down and we can add another double bond, which is going to make this carbon satisfied with 2, 4, 6, 8. And then the final one just needs one more hydrogen. 2, 4, 6, 8. So I've only drawn in 2 of the fatty acids to show the difference between the 2, but remember, we need another to add another fatty acid here. But these are the building blocks. So again, we said this one is a saturated fatty acid, and this one was an unsaturated, or we could even say it was a polyunsaturated, but it is an unsaturated fatty acid because every single carbon is no longer covered in hydrogens. And remember, we said everywhere there's a double bond, there is kinking in the chain. And then we just need to go back and label this a glycerol molecule. And remember, we would follow this by dehydration synthesis in order to produce a triglyceride. Okay? And remember, our triglycerides can either be, depending on what kind of fatty acids we put in, is going to determine whether we've produced an unsaturated fat or a saturated fat or a polyunsaturated fat. Okay, let's go on to the next one. The building block of a protein are amino acids. They have a central carbon, and off of the central carbon we have 4 things that you'll always find on an amino acid. So we said amino acids are the building blocks of proteins. Amino acids are the building blocks of proteins. Now, so what should we always have? We're always going to have a central carbon, and off of the central carbon we'll always have a hydrogen. We always have an amino group because it's an amino acid. And then what makes things acidic? We said a carboxyl group, so a C double bonded to an O with an OH. And then it'll always have an R group. In class, remember the R group, I'm not going to make you draw each individual R group. I just want you to know that each individual R group is what's going to make each individual amino acid what they are. So depending on what's in this position down here, where the R group is going to determine which amino acid that you're going to have. And that can be something as simple as a hydrogen or something complicated like a ring. So a ring of carbons joined together. So depending on the R group is what's going to determine. Remember, there are a total of 20 common amino acids. Common amino acids. Okay? And they fit into 3 categories. You have a hydrophobic or nonpolar group. You have a polar group and an ionized group. Okay? So those were the building blocks. Thank you very much. Oh, and I forgot one, and I should do that one. Let's see if I can create one. Can I grab a slide? Let's go over here and see. Can I grab a piece of paper? Yeah, because I did not show you the building blocks for the nucleic acid. So the nucleic acids, and we'll just nucleic acids. You've done this in lab more than once, so you should know what the building blocks of the nucleic acids. We know that the nucleic acids are built of nucleotides. That should be a U, nucleotides. That's a U. Okay, so nucleotides, and nucleotides consist of 3 things. And this is all you have to know. You won't have to draw them individually, but they contain a 5-carbon sugar. They contain a phosphate group. And thirdly, they contain a nitrogenous base. If we looked at, and I'll grab another piece of paper real quick, and let's look at DNA and RNA as our first 2 examples. The bases that we'll find in DNA are adenine, thymine, that's an M, guanine, and cytosine. So those are the bases for DNA. For the bases for RNA are adenine. Instead of thymine, you're going to have uracil, and then guanine, and cytosine. The sugar that we'll find in DNA, 5-carbon sugar, is going to be deoxyribose. And the sugar that we'll find in the 5-carbon sugar that we'll find in RNA will be ribose. Okay. And then there are other nucleotides that you'll have to know, but we'll talk about those later. But the building blocks, again, for the nucleic acids are nucleotides. And those nucleotides Remember again, they are composed of a sugar, a phosphate, and a base. Real quick, the other nucleotides that we will look at in class are the other nucleotide, so this is still in the category of nucleic acids, are ATP. For ATP, it uses adenine as its nitrogenous base. It uses ribose as its sugar, its 5-carbon sugar. But then for the phosphate group, instead of having one phosphate group, so phosphate instead of one, the name suggests adenosine triphosphate suggests that what? It has 3 phosphate groups. So it has a nitrogenous base, a 5-carbon sugar, and 3 phosphate groups. Okay, and let's write this name: adenosine triphosphate. Okay, and let me do one other one that you're going to see. And that is, those are the nucleotide coenzymes, nucleotide coenzymes. And for right now, the only thing that I want you to know about the nucleotide coenzymes is that what they do. Okay, their job is to pick up hydrogen ions and transport them from one part of a reaction to another in order to build energy. Energy molecules, and you know that energy molecule is going to be in the form of ATP. Now, some examples of those that you'll see coming up in later chapters are NADP. You will see let me go back. Well, NADP, you will also see FAD. Let's just scratch that out. And you also see FAD, and then you'll also, so it should have been a plus sign, I'm sorry, NADP plus FAD, and then you'll also see NAD. Okay, so those are the 3 coenzymes that you're going to see. Once they pick up the hydrogen ions, you'll see NADPH become NADP plus become NADPH. Once FAD picks up its hydrogen ions, it will be reduced to FADH2, and then NAD will become NADH. Okay, now, again, the only thing that I want you to remember is this portion for now. Okay, I want you to remember the name and then what they do. And then in later chapters, we'll come back and show them doing what they do. All right, have a wonderful day. See you later.